Hi, I wanted to go through and make sure I got you a solution to this practice exam that I gave you last time. Again, sorry I've been a little under the weather, and I just want to get caught up and make sure that I'm helpful to y'all getting what you need. So, here's the key, here's the date, and this is for E and G period. So here we go. First of all, let's just be kind of clear. We've got three formulas for energy. The kinetic energy formula, EK, is going to be 1/2 mv squared. And so we got some straightforward things to sort of warm you up. Please remember that kilograms means mass, and 4.0, well, when you see meters per second, that means V. So we've got 1/2 mv squared. That'll be 1/2 times 2 times 4 squared, which is going to be 16 joules. And then here, we've got 40 joules of energy, and the spring constant is 20 newtons per meter. So when we get the elastic energy, that's going to be 1/2 kx squared. And we want to figure out how much it's been stretched by. So let's be kind of clear here. This is the spring constant K. This is the amount of energy that it has, and this is why I really emphasize learning the units. Okay, so units for K are newtons per meter, units for energy are joules. And so what we're going to end up getting is that 40 equals 1/2 times 20 times this x squared that we're solving for. And so that's going to be 40 equals 10 times x squared. We divide both sides by 10. And we'll get 4 equals x squared. So x actually ends up being 2 meters. Then we have a 2 kilogram ball moved to a height of 10 meters, and we want to know how many times greater is the gravitational energy of a 1 kilogram ball moved to a height of 40. So let's be clear. First, let's get the 2 kilogram ball energy. That's going to be mgh, which is going to be 2 times 10 times 10. So that's going to give us 200 joules. And for the 1 kilogram ball, we're going to have mgh, but now it's going to be 1 times 10 times 40, which is 400 joules. So when we say how many times greater, that's another way of saying ratio. So 400 divided by 200 gives me a ratio of 2 times greater. All right. So that's kind of sort of the introductory stuff. So if you notice, we introduced 3 energy formulas here, just to be clear. So I want to do a small little review here of some ideas just before we move on. So remember, kinetic energy is 1/2 mv squared. Gravitational energy is m times g times h. And elastic energy is going to be 1/2 times k times x squared. And let's be clear that m is mass, v is speed, g is the gravitational strength, height is h. The one that confuses people, I just want to go through and label these because I think you're okay with the other ones, just to be safe. Just be clear. K is the spring constant. That's newtons per meter. And x is the stretching or the compression. That's in meters. So K is the spring constant. And x is the stretch or compression. Just to keep that clear. Okay. Just wanted to make sure we kind of review those ideas. So now it says you and your friends push a 1,500 kilogram car along a level road, accelerating it from rest. We're going to treat this as spring energy. And we transfer 7,750 joules of energy into the system, and 1,000 of that is dissipated by friction. So first we want to get our energy bar graph. So we're going to start with all this elastic energy. And we're going to get some kinetic energy, and a little bit of it lost to friction. So that's how we shade in the dissipated energy. And we want to know how fast the car will be traveling after the push. So here, this really means use conservation of energy. Okay, like don't try to solve for some kind of, when you're doing an energy system, an energy problem, don't try to do crazy math to start with. Simply set up your energy equation based on your bar graph. And if you notice, I'm doing this addition thing. Sorry, I don't like this letter. This should say dissipated. Sorry about that. But just to be clear, once you set up this bar graph, you take this here, you set it equal to this guy plus that guy. So I'm just adding all the bars. So I have 7,750 joules to start with, and 1,000 of that gets lost as dissipated energy, and I'm left with kinetic energy. So first, let me just get the amount of kinetic energy in the system. And I can use that to get the speed. I suspect, by the way, see, let me just say one thing here. It says, how fast will the vehicle be moving? Okay, when I see the word fast, that makes me realize I'm going to need to know the kinetic energy in order to get it. That's kind of my idea here. That once I get the kinetic energy, then I can get the speed. So it's almost like when they say how fast, what they really mean is come up with the kinetic energy and then work backwards to get the speed. So we'll get 6,750 joules is EK, and now I can go ahead and get the speed using 6,750 equals that 1/2 times m times v squared. And they actually give me m in the problem as 1,500. And so I have 6,750 equals 750 times v squared. And let me go ahead and isolate v. I'm going to divide both sides by 750. So this cancels. Cancel this. And let's see. You know what? I'm not even going to bother to do. I could, but I just. So I'm getting 9 is v squared. And so that's going to give me a v equal to 3 meters per second. So that is page 1 of the practice exam. And in the next video, I'll take a look at page 2.